Hello everyone, the problem we're looking at today is the USACO 2019 January Contest Gold Problem 1 of Cow Poetry. You can pause the video first and read the problem by yourself if you want. So the problem statement is basically Bessie is trying to write poems, and then she's trying to write an M-line poem following a specific rhyme scheme, and there's also N words that she knows. And she also tried to make the poem, each line to be K syllables long, and M lines, obviously. So the rhyme scheme works like this. It's going to be M letters, and each letter means which rhyme class it's going to be, basically, except the rhyme class is not specifically appointed. So, for example, if it's ABA like this, the first line must rhyme with the last line. However, they don't have to be specifically rhyme scheme A, which, as you can see, rhyme schemes are all rhyme class are all numbers, so it can't be rhyme class A. So it just means that all the lines with the same letters rhyme with each other. They're all in the same. They all end with the word with the same rhyme class. However, rhyme class is different from rhyme scheme, which is kind of confusing for this problem. A rhyme class is what class this word is rhymed with. So, for example, word 1 has length 3 and rhyme class 1, which means it rhymes with word 2, which also has rhyme class 1 but has a length of 4. And they don't rhyme with rhyme class 2, which is the third word. So, for example, a poetry you could write with this would be word 1, word 3, word 2, and that would follow the rhyme scheme. However, that would still not be a valid poetry because it doesn't have a length of 10. So you just have to add a few more words before them. But they all have to end something like this. Word 1, word 2, word 1, word 3, word 2, or say word 2, word 3, word 1. Anyways, hopefully you understand the problem. It's kind of confusing because there's a rhyme scheme and a rhyme class. So you just have to be able to tell the difference. Or maybe if you're more into poetry than I am and you already know what they are. So what do we do for this problem? First of all, since we're trying to count the number of different poems you're going to write, and given all these words and combining and stuff, you can kind of tell it gives off a strong DP vibe. So that's the first thing I tried, DP. So obviously we want kind of a pre-process in which we find the number of ways to write a line with a certain number of syllables. Because knowing that, we can then compute CNTN equals the number of ways to make a line rhyming with the ith rhyme class. It's going to be easy because it's just going to be sigma fi minus sj, which is the length of the word. And that contributes to the number of ways to write a line that ends with rhyme class cj, right? So now we know CNCI, number of ways to make a line rhyming with the ith rhyme class. A lot of other stuff are going to be easier. Right now, we just have to, for the rhyme scheme, for each letter in the rhyme scheme. So for A, we just have to enumerate which rhyme class do we put rhyme scheme A into. So it can be either rhyme class 1 or rhyme class 2. So then for each line, we just enumerate that, and then we do the same thing for B. So to visualize this, let's make a diagram. So basically, for the rhyme schemes, we have, say, rhyme scheme red, rhyme scheme blue, rhyme scheme red again, it's like the US flag, and then you have different rhyme classes. So, for example, you can enumerate whether we match rhyme class yellow to red, or we match green to red, or we match gray to red. And once we've decided on which one to use, say we've decided to use yellow, then this one also have to end with a word that has rhyme scheme of yellow. So both of these have to be like that. And if it's green, they all have to be green. If it's gray, both of them have to be gray. And then we just have to figure out the number of ways to write a line that ends with yellow. And so it's going to be this, but squared, right? Because those two lines are completely independent of each other. So it's just number of ways to write this times number of ways to write this. But we know they're both the same length and both end with the same rhyme class. So it's just CNC of length minus CNC of length and the rhyme class yellow squared. And same thing for blue. And if we have other new rhyme classes. So then here's my code. First of all, we've pre-processed fi, which is just the number of ways to write a line with I syllables. And with fi, we can easily find CNTI, which is the number of ways to write a line that ends with the CIth rhyme class. And straightforward, just like this. And then we do a sort kind of thing, which is like discretizing, because when we input it, all the rhyme classes are not necessarily adjacent, right? It could be like all the C's are, say, rhyme. We have rhyme class 1, 3, and 5, and that's just very inefficient. So after we sort them, we're just going to be having rhyme classes 1, 2, and 3, right? That's a lot more convenient than 1, 3, 5. So after we sort them, it's like a tiny discretizing process. And now we can easily deal with each rhyme class, and we know there's almost 26 of them. If it hasn't existed, we skip it. If it did exist, we do a fast power, just like I said. For 2 of the same rhyme scheme, we just do squared, but for n of them, we just do to the nth power. So we had to do a fast power, which classic fast power, everyone knows how to write that by now. You do fast power of CNTJ raised to the gth power, and gi is just the number of times this rhyme scheme existed, so obviously. And then mod p. P is just 189 plus 7. And answer real time, answer now times the real answer, and then output the answer. Okay, pretty fun problem, I would say. During the mock contest, I was actually stuck on this process. I was not able to find the number of ways to make a line of the length I. I did kind of like a complete knapsack or whatever, but I kind of failed. But this is also the first problem I solved in 2025. Yay. Okay, hopefully after this video, you'll know how to solve the 2019 January contest gold problem one of Cal Poetry. Thank you for watching, and I'll see you tomorrow. Okay, that was the problem review. You can go ahead and click out if you're just looking at the solution for this problem. And now is the grind report. As you can tell, I'm kind of tired today for some reason. Didn't wake up kind of late. And then I solved one problem, the P1080 on Logu, which is the one that we looked at yesterday, I think, actually. It's a really, really classic greedy problem. And it also requires high accuracy or high precision, whatever you say algorithm, but it's just that one algorithm in which you basically manually what's the word? I'm tired. You simulate the process of addition or multiplication in which you store a number into an array so you can store bigger numbers. In this case, it's a number with at most, like, I think 4,000 digits. Obviously, you can't use any int or long to store that, so you just use an array, and you have to simulate all the multiplication and division here. So you can see high precision multiplication, high precision division, and there's a high precision comparison as well, because you have to compare them digit by digit when you store them with an array. So yeah, this is a pretty complicated problem, and I'm very rusty, so I got a bunch of bugs in here, but I can see I'm kind of getting my skills back from January. Still gonna take a while to fully recover to my not just coding skill and also my problem solving skill back in January, but I can see it's getting back to me, kind of. Hopefully this summer break can be even better than January. Okay, thank you for watching, and I'll see you tomorrow.